Hi, I want to put a video together for you and kind of help you out with the recursive and explicit formula. So let's put I'll share my whiteboard with you and then we'll go from there. So now let's just say we have a sequence. We have a sequence of A1 is equal to 3. Okay, A2 is equal to -10. A3 is equal to -23. A4 is equal to -36, so on and so forth. Now, so what you really have to remember and understand is the n is the numbered term. So what this is saying is the n is 1 here because this is the first term. The n is 2 here because that is the second term. The n is 3 here because that's the third term. So that's really important to understand, okay? And if I want to say a to the fifth term, if I want to find this, I'll just have to subtract, that would be -49. So the a fifth, so this is the fifth term is -49. So understand that dynamic there, okay? Also, you have to understand the differences between arithmetic and geometric sequences. Arithmetic sequences are separated by a common number, okay, or a common difference, and geometric sequence is separated by a ratio, okay, or let's just say if I said like 5 and then times 3 would be 15, times 3 would be 45, times 3 would be 135, so on and so forth. So this is a geometric ratio. And then this is right here what we're doing is, this is an arithmetic, so not ratio, it's arithmetic sequence. This is a geometric sequence. The reason why this is called geometric is because it's separated by 13, by -13. Okay, so if I want to make so before you start putting in numbers into formulas, you have to determine whether the series is arithmetic or geometric. Okay, so the first one is arithmetic, okay, or this series right here is arithmetic because it's separated by d is equal to -13. Now you're going to use this formula, two formulas. There's called explicit and recursive. Okay, explicit is based on the first term. Okay, so a sub n is equal to a1 plus then n minus 1 times d. The recursive is based on the previous term. So yeah, if you have an arithmetic sequence that is, and then you want to find the recursive formula, it is a sub n is equal to a n minus 1. This means the previous term plus the difference. Okay, so if I want to find the explicit formula for this sequence, first of all, this equals, what's the first term? The first term is 3 plus n minus 1 times the difference is, you're subtracting, so it's -13. And so if you distribute that, that's going to be 3 plus, or actually minus 13n plus 13. Combine like terms, this is 3, this is, so it would be -13n plus 16. So a sub n is equal to this. Now, why is this important? It's because imagine if you had a series like this and you want to find the 100th term. Well, you're not going to just keep subtracting 13. It's going to be a big pain just to keep subtract 13, 13, 13. You're going to do it 100 times. Instead, why don't you just know that since you have to find the 100th term, n is going to be 100. So you're going to subtract, 13n, 13 times 100, it is -1300 plus 16 will be -1284. Okay, now how do I express this as a recursive formula? Well, I'm using the previous term plus the difference. So what's the difference? So the difference is a sub n minus 1 minus 13. And that is your recursive formula. Okay, now what if we had a geometric sequence? Something like this. All right, if we had a geometric sequence, let me clear that. Let me clear this here. If we had a geometric sequence of 5, 15, 45, So I don't think it's 145 times 3. Yeah, it's 135. 135. Okay, that means the ratio is 3, correct? Because you're multiplying by 3 to get to each number. All right, well, if you're going to get the explicit, remember the explicit formula. So now, sorry, this is a new concept. Explicit formula is a sub n, a1 times r and then n minus 1. So for a geometric sequence, and you're trying to find the explicit formula, you would use this formula here. So the a sub 1 is 5 times the ratio is 3, and then n minus 1 equals a sub n. So how would you do that here? Well, let's say if I wanted to find the fifth term. The fifth term is what? So 5 minus 1 would be 4, right? 3 to the fourth power is what? 3 to the fourth power, so it's 81. 3 times 3 times 3 times 3. 81. 5 times 81 is 405. So this would, the next sequence would be 405. So wouldn't it be so much easier if you just had this formula right here, and you know, let's just say we had to get the 100th term on this, just put 100 here and then go from, and then get the 100. So 100 minus 1 would be 99. 3 to the 99th power multiplied by 5, instead of just doing it repeatedly over and over and over again. That's what this is for. So now what if we need to get the recursive formula? The recursive formula is an is equal to r times an minus 1. All you have to do is just fill in the ratio. So the ratio would be 3 and then an minus 1 equals 8. And this is your recursive geometric formula. Okay, that is it. Let me know if you have any more questions. Thanks, bye.